Does anybody know what that stuff is? Magnesium. Yes, it is. Magnesium ribbon. So magnesium is an element on the periodic table. That's here. And it is a metal, which is why we can make it into ribbons. It's quite malleable, which means you can sort of pound it into different shapes. But it is quite reactive. In fact, it's very reactive, which we'll take a look at in a minute. It is the 11th most abundant element in the universe. And because it is reactive, and because it is abundant, it actually means that it's quite useful. The body uses magnesium in a lot of the chemical reactions that go on inside the body. Do you know what the chemicals are called which help reactions along in the body? Oh, that's it. Enzymes. Yeah. Enzymes help catalyse reactions in the body. Enzymes need specific, or some enzymes need specific elements to aid those reactions. And actually magnesium is quite useful in a lot of the reactions which go on in the body. Like I say, it's very reactive and it's quite abundant, which means that it's used throughout the animal kingdom. They use it in medicines, they use it in fertiliser. So it's all quite, it's quite good stuff. Right, so we can get an idea of magnesium's reactivity by lighting it. Now then, when I do light this, this glows extraordinarily brightly. If you stare at it, you can damage your eyes, so don't look away from it every so often. It's really quite bright. But once it gets going, so very bright light. In fact, extremely bright. I'm heating it, and it produces this white, white sort of ash, which goes on the floor. So it is quite reactive, but we got some chemistry to happen there. We started off with magnesium. The chemical signature for magnesium, or chemical symbol for magnesium, is Mg. But once we lit the thing, we were burning it. What did we produce? What does that mean that the white ash stuff was? It gives us magnesium oxide, MgO. So there we go. The first thing that we've done with magnesium is we set it on fire, caused the chemical reaction, and we got magnesium oxide. Nice and easy. Okay, so the question is, what makes magnesium magnesium? And the thing that makes magnesium magnesium is the fact that it has 12 protons in its nucleus. Now we will get to the structure of the atom down here, so don't worry too much about where all these things are. But magnesium is magnesium because it has 12 protons in its nucleus. If it had 13 protons in its nucleus, magnesium's here, if it had 13 protons in its nucleus, it would be aluminium. And if it had 11 protons in its nucleus, it would be sodium. So the thing that decides or differentiates one element from another is the number of protons, specifically the number of protons that they've got in their nucleus. Oxygen's got 8, carbon's got 6, nitrogen's got 7. Magnesium has got 12, based on. The Greeks came up with this thought experiment, and they had this idea of if you had a rock, and you can break a rock in half, and then you've got two pieces of rock, which are half the size of the original piece of rock. You can take one of those halves and you can split it in half again, and then you can take one of the resulting halves and you can split it in half again. And the philosophers at the time thought to themselves, well, can you carry on doing that indefinitely? And they came to the conclusion that there was a fundamental building block of stuff, of matter, which they called an atom, which actually in Greek means indivisible. And they imagined this atom as being like a snooker ball. And they imagined that atoms made up matter, and they weren't actually that far away from the truth. This idea of the atom being the basic constituent of matter held right up until the beginning of the 1900s. At the beginning of the 1900s, we started to get a grip on things like production of X-rays and very high energy electromagnetic waves. you can use very high energy electromagnetic waves to start to investigate the structure of the atom. So up until this point they thought of the atom as a snooker ball. It actually turns out that the atom there's more to the atom than just this idea of it being a snooker ball. And the atom has a centre, which is what we call the nucleus. So if we imagine this as being magnesium, magnesium has got these 12 protons in its nucleus, so actually you can break 1, 2, 3.
So it is central.
Yeah, the nucleus is right slap bang in the centre of the atom, and actually the nucleus is teeny tiny, and most of an atom is 99% of an atom is actually just air space. There's a gap between the nucleus and the 12 protons. Protons have got a positive charge. So if we have 12 positive things, but the actual overall atom actually has a neutral charge, what do we need? We want to have 0, but we've got plus 12. Yeah, we need a minus 12, so we need 12 negative bodies. Okay, so we're starting to get a build-up of an idea of the things which are contained in an atom. So protons in the middle, and electrons actually orbit around the outside. And there's that. Okay, so you do have these subatomic particles called neutrons that also live in the nucleus, but don't have any charge. If we added one more proton to that, it would cease to be magnesium and it would become aluminium. And you'd also need to add another electron. Just for comparison, a helium atom would be 2 neutrons, 2 protons, and 2 electrons. That's helium. Protons, neutrons and electrons, the 3 ingredients of an atom. Now, in terms of this, and we will come on to this a bit more in medical physics, but it is possible for an atom to lend an electron to another atom. And this is where they become chemically bonded. Which does mean that your original atom, because it's got 1 electron too few, will actually have a positive overall charge. And that's something that we would think of as a positive ion. So we call it an ion. It is also, some other atoms would actually borrow an electron from other atoms, and that would have 1 additional electron and therefore an overall negative charge, and we would think of that as a negative ion. We can have this idea of an atom giving away an electron or borrowing an electron. We can actually also increase the weight of the nucleus without changing the number of protons in it by adding neutrons. Because neutrons are neutral in charge, you can actually add more neutrons and leave the atom overall the same number of protons, same number of electrons. Those where you've got more neutrons are called isotopes. And isotopes we will come back to in medical physics. So this 24 number is actually the number of protons and the number of neutrons added up. So Mg24 has 12 protons and 12 neutrons. Mg25 has 12 protons and 13 neutrons. And Mg26 has 12 protons and 14 neutrons. You can add more neutrons in, you get a heavier nucleus, but you don't change the chemistry of the atom itself. And we will come back to this idea of isotopes in medical physics. Which actually then makes the nucleus unstable, and it will then be tempted to produce nuclear radiation. So you can get these heavier isotopes. That's actually a radioactive element, Mg26, because its nucleus is heavy and consequently unstable. Okay, but again, we'll come back to these ideas. I think it's nice for you to be introduced to them, but we'll come back to them properly or in anger in medical physics.
So how does the